Hi everyone, here in this video we are going to analyze the interesting problem which is given on my Facebook page ChemWorld. Nearly 2000 people reached this problem, but no one has given the correct answer, or no one predicted the correct answer from the given four options. So here, without knowing the reaction and its mechanism, one can give answer for this problem by just having the standard basics of chemistry with logical thinking. Okay, right. And first look at the problem and how it is made. So we have given with iminopasporine. Okay, so the reactant is iminopasporine with Martin's ligand. Okay, yeah. So iminopasporine is given, and which is reacting with DMAD, dimethyl acetylene dicarboxylate, okay, followed by reacting with water. So here we have given with four options. Just look at them. In the first option, so we have a four-membered ring cycloaddict of heterocyclic compound. That means four-membered heterocyclic compound is given. Okay, if you look at third option also, so there is no difference between first and third options, but to drag the concentration of aspirant, the geometry is drawn somewhat different from first option to third option, but there is no difference. Okay, the product is same in first option and first option and third option. Okay, the geometry just dragged. Okay, so geometry is changed. Okay, so that's why here 1 and 3 options are same, and by just looking at 1 and 3 options, so many aspirants are just stopped at 1 and 3 options, and they predicted answer in 1 and 3 options only. Okay, and just look at second and fourth options. Here we have a 5-membered heterocyclic rings, okay, so which are newly formed in the product. And by just analyzing options also, now just look at the reactant and reaction conditions. So here one can expect simply that there is 2 plus 2 cycloaddition to make a 4-membered cycloaddict. Okay, 4-membered heterocyclic addict. Okay, and this is the first step of the reaction. Okay, and so many stops here, and predicted the option 1 and 3. Then what is the working, or what is the work of water molecule is here. Okay, we have taken two specially, that means we have mentioned two conditions in the reactions. The first is with DMAD and second with water. Then what is the work of water here? Okay, then one should think deeply here from the basics. Okay, yeah, this is the 4-membered ring which is formed in the first step. Now the 4-membered heterocyclic ring has a double bond with adjacent heteroatoms. Okay, we know that 4-membered ring is unstable, and with the double bond and with adjacent heteroatoms it is more unstable. Okay, that's why here one can expect the cleavage of this 4-membered ring. Okay, so whenever the 4-membered ring is cleaved, then we have other possibilities, only 5-membered rings. So here we have second and fourth options. Okay, second and fourth options we have 5-membered ring. Then answer will be in second and fourth option. Okay, so this is the wise thinking now. Right, after come to the 5-membered ring possibility here in this reaction. Now just check second and fourth options. Right, so which will be the correct product? Okay, so if you look at the fourth and second options, and if you look at the bondings on phosphorus, in fourth options 2 oxygens are adjacent to each other, whereas in second option 2 oxygens heteroatoms are opposite to each other. Okay, so in common thinking, from the general principles of stereochemistry, whenever these 2 hydrogens, here 2 oxygens are adjacent to each other, they have lone pair of electrons on them. Okay, so those lone pair of electrons can make a steric repulsion. That's why this geometry is not correct fit for it, and the product of option 4 is unstable one. That means the minor product, or we can expect the minor product of as the fourth option. Okay, so simply second option must be the correct answer, right? So here the option 2 is the correct answer for this problem, right? By just having basic knowledge in the standard basics on each and every topic of chemical sciences or chemistry, simply here from the lowest levels of competitive examinations on chemistry, so one can give answer by just a logical thinking. Okay, just apply logical thinking whenever you are unable to give the correct mechanism and correct product. Okay, so whenever we have the correct mechanism, just go through it and give the answer. But whenever you are unable to give answer perfectly, then go with the logical thinking and just apply some basics of chemistry. Okay, so you can get 90% of answer from them, right? Okay, then now come to the concept involved in this reaction, right? After formation of cycloaddict, heterocyclic, 4-membered heterocyclic addict, okay, then the function of water. So as we said, the 4-membered ring is unstable here with the 2 heteroatoms and 1 double bond in it, so it can cleave. Okay, so it cleaves here, right? And then the water going to attack. So you can see with that explanation on the mechanism here, that is the best thing. So in the first step, after formation of 2 plus 2 cycloaddition, right, the cleavage of 4-membered ring takes place. That means ring opening takes place. After it, just follow the arrows here. Okay, in the next step, the water molecule, which is acting as nucleophile, going to attack on carbonyl carbon, and negative charge on nitrogen takes the proton from it. Okay, so here is the formation of a 5-membered ring. Okay, and in the second option, as we said, 2 oxygens are at the same time or near to each other. The lone pair of electrons can get a make a steric repulsion, and that is the unstable product. Okay, so that is, sorry, here the fourth option. Okay, right. And if you look at the again on phosphorus, so here is the more accurate reason we can give. Okay, so that is, if you look at the phosphorus here on reactant and the products, it is with 5 bonds. Okay, one with tri-isopropyl, the large ligand, and two bonds here with 1 oxygen and 1 benzene carbon, and here with 1 oxygen and 1 alkenic carbon. So 5 bonds are there. So whenever 5 bonds are there on phosphorus, it is having 10 electrons in its valency shell. That means phosphorus is in hypervalency. Okay, phosphorus here, the species is having hypervalent phosphorus. And if you look at the geometry of this phosphorus, it is simply a trigonal bipyramidal geometry. Okay, trigonal bipyramidal geometry. And on the trigonal bipyramidal geometry, the heteroatoms, okay, the heteroatoms with more electronegative heteroatoms must be on axial positions to make 3-centered 4-electron bonds, which can explain hypervalency. Okay, so here by this valid reason, we can also give option 4 as option 2 as the correct answer, where phosphorus having 2 heteroatoms, oxygens, which are more electronegative heteroatoms, or simply axial on phosphorus. Okay, and other bonds are equatorial. So that's why here second option is the correct answer, right? So please visit chemmasters.online website or download mobile app Chemmaster from Google Play Store to join the courses CSIR, NET, GATE, EDGAM, M.Sc Entrance, and DL, and for IIT Chemistry. So just play on mobile and get the strongest concept to get the success in your competitive examinations on chemistry. Thank you.